Hey, I'm Mitchell. Welcome to another video in the RSP Education series. In this video, we're exploring three advanced types of proximity sensors: capacitive, photoelectric, and ultrasonic, each with unique capabilities that make them essential in modern automation. From detecting clear plastics in high-speed packaging lines to sensing liquid levels in sealed containers, these sensors are solving complex problems every day. Whether you're trying to select the right sensor for your application or just want to understand how they work, this breakdown will give you practical insights into where and why each sensor type is used. Stick around. You might just discover a solution to a challenge you didn't even know had a name. If you like this kind of content and want more educational videos, please like and subscribe. Also, this video is for educational purposes only. Consult a professional for your application. RSP Supply is not liable for any misuse of this information. With that said, let's get right into it. So, capacitive proximity sensors. These detect both metallic and non-metallic objects, including plastics, glass, wood, paper, and even liquids. Its best fit application is in detecting objects in packaging, food processing, and level sensing of materials and containers. Its drawback: it's more sensitive to environmental conditions like humidity and dust. Photoelectric proximity sensors. Its function is to use light, typically infrared or visible light, to detect objects. They come in three main configurations. A through beam configuration. That through beam means there's a light emitter and a receiver, and these are separate. The object is detected when it blocks that beam. Retroreflective. It has an emitter and receiver in one single housing, and a reflector bounces the beam back. Object detection occurs when the beam is interrupted. Then you have diffuse reflective. This sensor emits light and receives the reflected light from the object itself. Its application fit: it's versatile for detecting transparent, shiny, or colored items over long distances. Its limitation: it might be affected by ambient light or dirty lenses. Then you got ultrasonic proximity sensors, and its function is to emit high-frequency sound waves and detect objects by measuring the time it takes for the echo to bounce back. Its best fit application is for measuring the distance to an object or detecting clear or irregularly shaped items where optical sensors might struggle. Its drawback is that its performance can be influenced by temperature or air pressure or angled surfaces. So how do each of these work? Each proximity sensor operates on a different physical principle. Inductive sensors use an oscillator to generate an alternating electromagnetic field. When a metal object enters this field, it causes a disruption called an eddy current, which then reduces the amplitude of the signal. The sensor detects this change and registers the presence of the object. With a capacitive sensor, it has two plates that form a capacitor. When an object with a different dielectric constant or its material property enters the electric field between these two plates, the capacitance changes. The sensor detects this variation and it interprets it and translates it as the presence of an object. So photoelectric sensors, these emit an LED beam of light, and the sensor either waits for the beam to be interrupted, that's by the through beam or retroreflective models, or for the light to reflect off an object and return through the diffuse model. A change in the received light signal triggers detection. Ultrasonic sensors, these emit ultrasonic pulses, sound pulses, above human hearing range, and they measure the time it takes for the sound to travel to an object and back, the time of flight. Based on this time, the sensor calculates the distance and detects if an object is within a specified range. Where these are used, proximity sensors, they're widely used all over automation and beyond. Here's some common applications. In conveyor systems, it's going to detect when objects arrive at a certain point for sorting, counting, or diverting purposes. It ensures the efficient flow of materials with minimal manual intervention. In robotic arms, these types of sensors are going to help robotic systems determine the exact position of parts or tools, used to initiate movement, stop action, or align components precisely. In packaging machines, it's going to confirm the presence of packaging materials like bottles, boxes, or seals. It ensures the process doesn't proceed without a component. This reduces waste and errors. In safety zones, sensors are going to monitor whether someone or something enters a restricted or hazardous area, used in machine guarding or interlock systems to stop machinery when breached. To wrap up, Capacitive, photoelectric, and ultrasonic proximity sensors each bring something different to the table. Capacitive sensors are great for detecting a wide range of materials, including liquids, non-metals. Photoelectric sensors handle longer distances and tricky surfaces like glass or shiny objects. And ultrasonic sensors, they're perfect when optical solutions fall short, especially in dusty, irregular, or transparent environments. Choosing the right sensor depends on what you're trying to detect, your environment, and how precise you need readings to be. Thanks for watching. Check out for the rest of our series for deeper dives into each sensor type and how to apply them effectively in the field. For a full line of sensors and hundreds of thousands of other industrial automation products, please go to our website. That's rspsupply.com, the internet's top source for industrial hardware.